Good morning, good afternoon, everyone. Welcome to the fourth session for CICS on the second day. We've got Jenny here from the IBM Labs at Hursley. Jenny's going to be presenting on resilience and scalability and new capabilities in CICS TS 6.2. Take it away, Jenny. Thank you.
Thank you, Rob. Hello, everyone. Welcome to this session. I'm Jenny He. I'm one of the technical development lead in the CICS TS development organization in IBM UK. It's located in the Hursley lab. So in this session, I'm going to go through some of the capabilities and in the CICS TS 6.2 around the resilience and the scalability. As you may know, CICS has had a long history. The first release started in July 1969. So it's nearly approaching 56 years of the CICS this software. Looking back, the releases in CICS TS version 3, there are a number of versions in version 3. There are a number of capability added around web services. Then version 4, we added event processing, enable JVM server, etc. Then coming to version 5 and the versions in 6. And increasingly, you can see CICS TS has been a transaction server, and it also enabled multiple programming languages on this platform. So it become a multiple language host server. And also we, as a development organization, my team adopt standard industrial skills and best practices around DevSecOps. And also we use common pipelines, etc., and automated testing to ensure our products is thoroughly tested before release. So looking at the release trend, on this table, you can see from the CICS, we list from the version 5.2 up to 6.2. So we often we have the number of years, at least 5 years in service, with 3 years of service extension. So at the moment in 2025, we got the CICS TS 5.5 will be end of service in September this year. Then in 6.2 was released in June last year. So it's nearly a year for 6.2 GA'd. And we have seen lots of customers upgrading to this new release. So CICS TS, we deliver our functions through the GA release, but also we do through other ways. So there are continuous delivery on the existing GA releases, in-service releases. So those will be delivered through APaaS for those features. Then you have the flexibility to apply if you would like those capability, and you don't have to. And we also have CICS TS open beta. So for example, at the moment, while we already GA'd 6.2 last year, we are working on the CICS TS, the in-development release, and we already got 3 open beta for it. The latest CICS TS open beta was released early this month. So you can have an early view what's the next CICS TS function coming in, so you can do the planning for your organization. Then we also incorporate ideas. If you have ideas you would like CICS TS to enhance, then feel free to submit your ideas. Then CICS will assess those ideas and see how we can incorporate into the CICS TS product. We also have other family of products around the CICS TS family. So for example, we have Ansible CICS TS collection and the Zeus Cloud Broker and app plugins for various industrial standard tools. that's a CICS TS ecosystem. So around CICS 6.2, we have around 3 themes. The middle one, improve security and compliance management. If you were in yesterday's session in the CICS track, my colleague Mark has gone through all the features in this area. Then we have another area around enhanced developer productivity, which have new capability if using Java or Spring Boot, Node.js, etc. And also in this session, I'll be focusing on the management and the resilience capability. So let's jump into that. So around this area, the number of highlights here, it's a lot of bulletin points. But for this session, we got this 40 minutes so left now. I picked up those in greens, highlighted in green, which I believe it would be very interesting for you to know. And for the ones which are in gray, I will point out where the documentation you can have a look, and you can also email me or get in touch if you like to know around those areas. So the first one I'm going to show you is about request in CICS, surging request in CICS, how CICS in TS 6.2 have been enhanced to handle that. You may know the configuration of number of tasks in CICS region. The first and foremost is max task. And it's a parameter when you start CICS region called MXT, which limit the number of user tasks can be active in the region at the same time. You can also control the number of tasks for individual transaction ID through the tran class. So in the tran class, it has 2 parameters. One is called max active, which is limiting how many tasks under this tran class can be active at the same time. Multiple tran ID can be classified under the same tran class. So for example, if you have transaction A and the transaction B, both under this transaction class, so on the screen I have HA11CLAS, then at the same time, they can only have 2 tasks being active across these 2 tran ID. So what happens if you have more requests come in to start under those 2 tran ID? Then you can configure another parameter called purge threshold, which means the from other requests arrived more than what's active will be queued if you configure the number with a number there. So if it's 0, there is no purge threshold. However, CICS do have a limit of number of task IDs in the region, so it's 5 digits. So that's a hard limit. Then each queued task under this purge threshold will have a task number. So for example, if you configure this purge threshold to 5, then if more requests arrived at more than 5, then beyond that will be task will be abandoned. Those requests will be abandoned with AKCC abandon code. So there are a bit more information around the existing behavior of those tran class configurations. For example, if you dynamically lowering this purge threshold, what will happen? So we have seen a number of, it's a very delicate numbers to control, as you can see, because your system can be tuned very well to under the normal circumstances. But what happens when you have fluctuated workload and the configuration you've got suddenly wasn't able to cater so many requests into the CICS? So what can end up if, for example, you have a purge threshold very large, then CICS can accumulate a large number of tasks in the region. So we have seen customers they got problem like in the region have a lot of CPU time at task attach time, and which impact other tasks in the region. So the CICS become unresponsive. So that's pre-CICS 6.2. So in 6.2, this release, we have optimized this. Now, even you got a lot of tasks in the CICS region, then starting another task, CICS now will become much more responsive. So that's one enhancement we got. And with that, you still can end up with lots of tasks queued in the region, which can spend a lot of time to get being processed. And your client may go away or may issue another request into the region because they haven't seen any response. That can be a detrimental effect even you have a queued task request in the CICS region because of that. So, but you probably don't want a KCC band because having a band in a CICS region doesn't, it's not a good practice, isn't it? Because it wastes the CICS resource in the region. So in the CICS TS 6.2, we provide an alternative behavior, which is for you to configure to be able to discard the request. So this behavior is controlled as a trunk class level and applied to all kinds of way of starting a task. So the behavior is controlled through a new attribute called purge action, which is showing on the screen here. This screen showing a trunk class configuration in the CIDA panel. The default will be a band, which is the AKCC band, so that when you upgrade your CICS region, CICS release to 6.2, you don't see any difference. But you can change your trunk class definition to use discard. So with this discard, if you change to this parameter option of discard, CICS will discard the request if the purge threshold has reached. With that, there is no AKCC band in the CICS region for that type of request. Then CICS will also to signal the discard when it's sensible and consistent with the behavior of other errors. I will show you later what kind of response will be sent back to the requester in what circumstances. Then CICS will also have a new message called DFH-XM0206 to show how many number of purges in the last 5 minutes for a particular trunk class. So an example message is showing here. It says a trunk class has had 2 purges in the last 5 minutes. So this message gives you a more active view of what's happening in the CICS region, although those purges already recorded in the CICS statistics. We also you will also see the purge action configuration in the trunk class statistics, and monitoring field will also record what's the number of queued tasks for a trunk in the trunk class when the task is started. As a complete solution, you will be able also to monitor a trunk class queue level in real time using a policy rule. So combined with existing behavior capability, which is if you do have lots of queued tasks under trunk class, you can still lower the purge threshold in which is existing behavior. And when you do that, then those purges will be AKCC banded. This is because those requests to start those tasks already holding in CICS, and the requester already gone away. So we can only use the band to signal this has happened. But that's only for this particular way of band purges. So this one shows you the system rule, trunk class, queued task, if you wish to use. There are a number of task-related policy rules. As you can see, already we got a trunk class queued task or trunk class tasks, and we also got user tasks. They all have a very similar way of to configure using the percentage. So what response will the requester or originator get? So starting a task can be through API commands. For example, start attach, start brext, bridge attach, or run trans ID, which is an async API. So for those API ways to start a task, they will get immediate response of if the request is discarded, then the response will be a new one called no start with a resp code 1, which signal the request is discarded. As a comparison, if the tran ID is disabled, the issuer will get a response of invalid request with resp 2 of code 12. For the exec start is a very versatile API command. You can supply a delay time to start for the request to be started, or you can specify a channel, a terminal. If that terminal is not available, then the request will be holding in the CICS region, and the issuer, the originator, may go away. So in this case, we cannot immediately respond the API that kind of discard response to the originator because it may already gone away. So the API response will be normal, which is the same as if a tran ID is disabled, for example. If you start using terminal to start a transaction, and if it's discarded, then you get a new message, DFH AC2059, to tell you the request results, the transaction is discarded because the threshold has reached. And other area potentially can start CICS task is, for example, CICS got HTTP request and go through web service or go through IPIC from IPIC request. So I've listed the way different transactions, IDs, and involved in those cases. Some are CICS supplied, but they can potentially involve in those cases, so that you can potentially configure the purge action and the purge threshold for them. So I've listed what's a response the client will get. So okay, so right, this is a bridge. So again, for the CICS bridge, you get web bridge, link 3270, and CICS MQ have a bridge or adapter. So for those cases, I also listed what are the response the client will get. So that's about the tran class purge action discard. That's a new capability in CICS. Hopefully that will help you to manage the CICS region better without accumulating a lot of requests under a tran class and the clients have gone away, then throw another request in. The next section is about SDT, shared data tables. So in shared data tables, it's a function in CICS you can configure for file as a shared data table. Then when the request to read a file, for example, write file update, is issued on a AOR, and that request that file is hosted on the FOR. For the shared data table configuration, CICS will switch to all the read requests prior to CICS TS 6.2 to run on the QRTCB in the AOR region. We know QRTCB is there is only one this kind of TCB in each CICS region, and a lot of things happens on QRTCB. So the more requests need QRTCB, those requests will need to wait until it has it being dispatched on this TCB to run. So in the CICS TS 6.2, we have made those shared data table read and browse request thread safe. This is because the TCP switch has been removed for this type of requests, so that those requests now can run on OpenTCP. Potentially, then you don't have to have it run on QRTCP. So the list of read and browse command, which can benefit from this CICS 6.2 enhancement, are listed here. They are the read or start browse, read next without the update or option, etc. And also underlying enhancement, which you don't probably won't notice much, but will benefit a large environment. For example, if you have hundreds, thousands of CICS region, ALPA is we have changed the SDT to use 16-bit of access, which is a ZOS resource. So CICS now can change, can allow increase that to 32,000 per ALPA. So in the large, if you have large CICS, a lot of CICS regions and which do those type of requests, then that will be a difference you will notice. But when updating a shared data table, that is still not thread safe, so which will continue to run on a QR TCP. Then on the AOR region, which then get shipped to the FOR region. The same as the loading of shared data tables. When you upgrade to 6.2, you may have a mixed operational environment. For example, you may have some CICS region are still in the back level release, and some you already upgrade to 6.2. So if your FOR has already upgraded to 6.2, for those mixed version upgrade situation, you can use a feature toggle on the FOR region called com-IBM's CICS.sdt.support CICS TS 6.2 equals to true in this case, so that the AORs which hasn't been upgraded to 6.2 will be able to talk to the FOR for those circumstances. The default is false, so if you don't specify it, it will be false. There were more information on the CICS documentation regarding this, so I appreciate I can't go through the exact details on this particular point. We also added new message to warn a CICS maintained shared data table when it's full. So the data table can have a user maintained, which is UMT abbreviated, and or CICS maintained. For the user maintained one, when it's full, CICS will produce a message. But for a CICS maintained data table, even if the data table is full, the request will not fail because the data will be right to the source data set of vSAN. So as a system operator to manage CICS region, you probably don't know that's happening. However, as a consequence, because the record is not in the data table, it's in the source data set, then those access to those records as a consequence will incur performance impact. So you probably would like to know when this is the case, so you can maybe change your CMT data table to reload it. So we now produce a new message. If that's the case, DFH FC0437, which can show whether the table is full or whether it's storage failure. This message is only issued once, which means it's issued only first time when writing to this CMT and it is full. It will not be issued for the following on writing request because you do not want, we do not want those message flood your CICS region log when the CMT is full and you still want your business operate, don't not impact the region. However, if the file is reloaded, then CICS will check again, then will issue the message if the CMT table is full again. So looking back, the thread safe feature for the SDT, we've done performance test, and this is a configuration for the performance test. For CICS performance test in our product team, we mainly focus on the CICS product itself, so that as a consequence, the business logic is very minimum. So we're trying to highlight what's the performance because of the CICS code change. So here we got 2 TOR talking to 5 AORs, then which will route the request to 2 FOR. And then we list all what's the exact detail when the performance was done, so you can refer to it later. And the number of commands combination in the test program, we mainly got a lot of read, 95%. And because those read are now thread safe, so those requests then is eligible to run on OpenTCP. We also configure application can be a non-thread safe, which always run on QRTCP. And we also got configuration on a thread safe application. So here is a thread safe application. As you can see, the blue line at the bottom is the 6.2 performance, and the gray line at above is CICS TS 6.1. We've run for this performance test. When the requests come into CICS as a lower volume, the performance between them, they are not hugely different. However, when the number of requests coming transaction per second going up, there is a particular point where the thread safe 6.2 version will maintain good response time because of the thread safe for the read request. Whilst the previous releases, you will get a bottleneck after that point. So hopefully this will help you if you use the SDT in your environment. Storage is always a key point in a CICS environment. CICS has been monitoring the ZOS storage as well as a CICS storage itself. So since 5.6, CICS will monitor and guard against the user region 24-bit and extended user region which is 31-bit in the ZOS storage, and it will issue periodically check those storage and issue message if needed. In 6.2, we are now expand this to 64-bit of storage. And also, previously, the configuration of those storage monitoring were through a feature toggle. We now change it to a sit parameter. So here, this page lists the sit option for those equivalent feature toggles. So if you're upgrading from 5.6, for example, to 6.2, then you are using the feature toggle, then you need to review your region sit parameter. You need to change to use the sit parameter way to do that. So as a question, performance improve. Will this performance improve for async parallel with less process time? So it all depends on, I would say, depends whether the tasks was waiting for how much wait on the QRTCP if previously. So yeah, it really depends on the region's configuration. If we look back on the result here, the response time has been improved on the 6.2, slightly in the lower number of lower, we said lower is already quite a lot, which is 5,000 transaction per second. So it will definitely, I would say, improve the response time looking at what's showing up here. Okay, so for the ZOS storage, appreciate that there are lots of SOS messages. So this is a handy table summarize what for different storage areas, what are the message numbers you can monitor on. And we also got the statistics report to show what's at that time, what's the region's situation at that time. And the CICS monitoring field called SMMVS SWT is a user task weighted because the storage for 24-bit and 31-bit was short. So the next area I'm going to show is CICS statistics volume. The CICS statistics is a very useful way for you to see what's in how the CICS region operates. And a region may have many resources installed. For example, may have a lot of programs, transactions, sessions, connections, etc. And you may have cloned all this across all your CICS regions. Then CICS statistics would be produced for those programs transactions. However, so if your production region, for example, they are cloned, you may find a lot of them are not actually used in a particular CICS region. So for example, in the TOR region, it may have programs or transaction populated there across maybe the same as AOR. That's just a makeup, making example up. But for TOR, you may not use those AOR regions with those ones, suppose for AOR, but the statistics in the AOR region will still show those programs and transactions. As a result, you may get stats SMF record for those unused resource, which have 0 counts. So, and it also cost CPU to generate those records and occupy the storage in SMF. And you transport the process in reporting tool, and those reporting tool would need to filter them out, or depends what the reporting to do. So it becomes hard to see the trees from the woods. There are CICS ideas raised to reduce those records with 0 use. So CICS 6.2, we have now have the design now applied to transaction statistics and the program statistics, which are mapped by those stats macros. So for those statistic records, CICS will not produce for them on the circumstances when it's of interval statistics or requested statistics or requested reset. So at those situation, those 0 count transaction stats and the program stats will not be produced. So you will get much more concise view of stats for those areas. But we will still produce those 0 counts at least once a day at end of day statistics. So it can appear in your stats, then you can still see, okay, in my region, I got those resources installed. The unsolicited stats is when you discard a transaction or when you uninstall a program. Those will still be produced, even the usage is 0 for them. So you can see as a record to know those are discarded at that time. Then when you install, it will also be produced when they are just installed. And the next interval, we will still produce them. Then you can see, okay, at that time, I got this one installed. It's newly appeared into my statistics. So hopefully that will give you not much more space freed in the storage and also in the tools process them. The next section I'm going to show you is on the API and the CICS translator. We added one option to API put container. The new option is called prepend. It already has a append option, which means the data, when you do the put container with append, you will put at the back, at the end of the existing data. But you can use prepend now to put the data at the insert at the start of this container. And this option is available for across all the languages we support on using, whether it's C, COBOL, PL1 or Java, and EXCI, you can all use this new option. Talking about the application program, you may come across CICS translator. CICS translator, it has been tolerating spelling mistakes in the program. For example, if you have execx assign ASRA reg 64, then CICS 6.1 and before, when you translate this program using the CICS version 6.1 translator, it will have a warning say, this parameter highlighted in red is not valid, and it will correct to say is ASRA reg S. So it's very not easy to find out what exactly went wrong. But it's a warning. People say, okay, that's my program passed. But in the end, you may not want a reg S because you do want a 64-bit of a register in these circumstances. So with 6.2, CICS translator will issue an error message instead of warning message and will fail the translate step with a return code 8. So subsequent job steps are not executed. So this is an example with the same source code in the application program and the compile translate using 6.2 library. Now you can see it's a return code 8 error message will say it's not valid and it's ignored. So you would need to correct the source code and make sure you do have the correct parameter. But if you haven't got the time around to do that, to correct the program, you can still use 6.1 translator to translate those programs and run on 6.2 region. So the last part of this session I'm going to show you are around the CPSM. CPSM is, you may have CPSM in your environment to manage of your CICS region. And one thing in the CICS region is user ID. And the RACF will send a type 71 ENF signal for all the listeners, which can be a CICS region when a user ID is revoked, for example. Then the CICS region listens when the SIT parameter called RACF sync equals to yes. Then the region will handle this event through a dispatched SRB, which is a ZS resource. So in a CICSplex environment, you may have hundreds of CICS regions all listening to this event for user ID being revoked, and all those hundreds of regions will use this, each will have need a dispatch SRB to act on this particular event. So which can cause a system overload in this case. So now in 6.2, we added a new option in the RACF sync SIT parameter called CPSM. With this new option, you can specify that on the mass and the win regions. So which means those mass regions will get, instead of those regions, maybe hundreds of them, mass regions, instead of themselves process ENF71, mass will get those ENF notified events and process them from CPSM, from CMAS, when the heartbeat happens, which is currently every 15 seconds. So for those mass region with this setting, those mass will not acting on the ENF71 instantly. It will happen when the CMAS mass heartbeat happens. Then we'll get that from CMAS. So if you still want a mass region to act very quickly, you can still use the RECAF sync equals to yes on those mass regions you think is necessary. And if you use this option on a CMAS region, it will be rejected and error message will be issued. Then with this setting on the mass region, you can use the RECAF sync yes, still specified on the CMAS region. And the EYU POM sec yes. Then the CMAS region will listen for this ENF71, then will process those. Then the CMAS will store in the mass data space available retrieved by the mass region at heartbeat. CMAS also will react to the ENF71. With this new mechanism, new configuration, which means less SRB are used, then your LPAR will not be experiencing those problems because large number of SRB is needed. So it will help in the LPAR, which has a lot of CICS regions in the environment. For the CMAS, you can now also identify a CMAS, whether it's if a CMAS is a maintenance point, and also CMAS manage a particular CICS or no longer manage CICS. So using those matches, you can answer the questions here. Then you will also see EYU CP0209 information message in the maintenance CMAS when it delete and re-add non-maintenance CMAS. So those new messages would help for you to for this CMAS circumstances. The next one is on the EYU DRAP space monitoring. This EYU DRAP, it hosts all the CICS administration definitions as applicable to the CMAS. It can be very large because it holds CICS topology if you have BAS configuration, it also hosts that. So it's all the information for CICS, etc. So it can be very large, especially if you have a large environment. And this file, if it runs out of space, the CMAS will issue an error message, then no further update can be processed until this file is enlarged, which also means you have to take down the CMAS. So you would like to know before it's run out of space, it's best to warn you, okay, it's going, what's the space utilization now? So we now have a new message, EYU XD1032 warning message in CICS 6.2 to say the EYU DRAP has exceeded, say, 70% of its extent availability, and it shows whether it's data, what's the percentage on data, what's the percentage on the index. So it will issue if either of the index or data components exceed those, and it's issued at those points, CMAS startup shutdown time, or when you import a CICS or when more than 10K new records added. So it will be issued at 70%, 80%, and 90 to 100% to give you a progressive view on this space monitoring. The last one is the CICS and the CPSM shutdown. For the when you shut down a CMOS, the COSD should be used. Then it shut down the CMOS processing. COSD will also initiate the CICS shutdown. But what if you come from another direction when you're shutting down CICS using CMT form to shut down? 6.2 now is also enhanced to shut down the CMOS if you use CMT form shutdown as part of the process. Right. So in summary, the 6.2, what I've shown you, it are the capabilities improve resilience and scalability. This is not the comprehensive list, and for all the enhancements and also in areas which I mentioned in the very beginning of those slides, you can see this link on the CICS topic, what's new in CICS TS 6.62. In that link, you can also find what's new in the CICS open beta to see what's coming up. So that's all from this session. If you have any questions.
We did get one question in the chat, Jenny, from Merle.
Yes, is this the performance figure?
Yeah.
Will improve for async parallel transaction. Yeah, so what I get I think if you have the capacity provided the system have other like storage also allows those parallel transaction or parallel tasks they can run, then it should improve the response time with SDT file read being thread safe.
Okay. Hopefully that answers your question, Merle. If you've got any concerns, we can take it offline. Thank you very much, Jenny.
Thank you.
Folks, you can give feedback via the QR code, or you can just click on the agenda and give feedback on the website. We're back in after lunch. Says Rob, what time is that? That's 1:45 UK time, and we're going to go through the sampling banking application with Justin Taylor and I think Tom Slattery as well. So I'll see you after lunch. Thanks for your time, everyone.
Thank you.
Thank you, Jenny. Thank you so much.